Welcome to How to Linearize Nonlinear Data using LoggerPro Part 2. In this screencast, I'm going to be showing you a different example than Part 1. And this example will have data that has uncertainty and uncertainty associated with it, or error in the measurement, and also labels of the titles and the units. So here we go. Go ahead and open up LoggerPro. And the data set that I'm going to use for this is from the worksheet called Writing Equations for Nonlinear Data. And I'm going to use data set 4. So I'm going to copy and paste this in. You can type it in if you'd like. So copy, paste. And I'm also going to look back at that worksheet and see what the titles were. So in the first screencast that I showed, the data didn't have labels, and it wasn't supposed to represent actual data. In this case, this might represent an object that is speeding up, and its location at 7 different instants in time. So the left-hand column we're going to call time, the right-hand column we're going to call position. Time is going to be measured in seconds, position in meters. So to do that, we double-click on X, we'll type in time, short name would be the letter T, units seconds. The y-axis, we're going to label position, short name X for horizontal position, units M for meters. Here we go. And we'll notice that once we did that, it labeled our y and x axes of our graph. And as soon as we typed in those numbers, it graphed our data, and you can see that it's a top opening parabola. All right, so we're going to follow the same steps as screencast number 1. I'm going to go fairly quickly through those. We identified that this is a top opening parabola. We're going to guess that it's a square relationship with the equation, the parent equation being y equals x squared. So we're going to square the x-axis, which is time. We're going to go up to data, new calculated column. We're going to call this time squared. I'm actually going to type that out. The short name is t squared, or t superscript 2. And this time we do have units. So the units are seconds squared. So seconds superscript 2, or s superscript 2. Just like before, we're going to put an expression in. This time we're going to select variables, time, and then caret 2 on the keyboard to show that it's time squared. Then click Done. To see the whole data set, we're going to go Page, Auto Arrange. And then we're going to make a new graph, so Insert Graph, and we go Page, Auto Arrange one more time so I can see all the graphs. I'm going to title this my original graph, so this is going to be original graph for data set number 4 from the worksheet. This is called the test plot, also known as the linearized graph for data set number 4. And since we want to linearize this, we decided we wanted to graph position versus time squared. On the y-axis, we're going to select position. On the x-axis, we're going to select time squared. All right, the graph is kind of squished, so it might be a little hard to tell that it's linear, but you can see if we stretch that out that it is fairly linear. We can click once on the graph and do a linear fit. In this case, since this is supposed to represent actual data, we'll see that the slope, that the correlation value is actually exactly 1, but there is an error. Root mean square error is 0.34. The correlation value of exactly 1 means that, at least to the order that this is being measured, that these data points basically do fall right along the line. This actually is more likely something like 0.999 something, and it's rounded up to 1. The root mean square error, however, tells us that on average, these data points are either above or below the line by 0.34 meters. So a very small amount. Okay, so we're going to use this to write an equation for our graph. And something to be pointed out, this equation that we write is actually going to represent the original graph and the test plot. And really what we want is an equation that represents the original graph. And so what we're going to do right now represents both. Okay, I'm going to go to my Word tools, and we're using our linear model, y equals mx plus b. Instead of y, we're going to use a letter to represent position. We're going to use the letter x, or horizontal position. Instead of m, we're going to type in the slope. In this case, 2.99 meters per second squared. Let's see how that turns out. There we go, 2.99 meters per second squared. I'm going to put parentheses around that just to show that that whole thing is the slope. And then our x value is time squared. I'm going to use our equation tools here. So instead of x, we're going to type in t and squared. And then our y-intercept in this case is minus 0.02 meters. Didn't quite fit, but there you go. Okay, so the equation that we're looking at here describes the position versus time graph for our original graph. And as you notice, this is an equation like using the parent function y equals something x squared, or y equals ax squared plus b. That equation describes this graph, right? So if, for example, we were to plug in a time like 3 seconds, you'd have 3 squared would be 9. 9 times this number, which is roughly 3. So about 27 less minus 0.02, you get a number that's like 26 point something. Actually, if we go back and look at time, when time is 3 seconds, our position is 26 point something. So this model, this equation actually represents our original set of data, the original graph. It also happens to represent what's called our linearized graph. Okay, that is it for this tutorial. Hope you enjoyed it.